6.4. More practice. Creating equations. Specifically from tables. Now remember to organize your work by putting the date on and make sure that you put your name on it. Mine's Tara. So for each of these examples, we should describe the relationship in words, create an expression. Remember, an expression is something that does not have an equal sign, using the independent variable. Create an equation which relates the dependent variable in terms of the independent variable, and let's graph it. Now, if you're watching this video, it means that you need a little bit extra practice, and there is no shame in that. I always needed a little bit more practice when I'm going from a set of data points and creating an equation from that. Sometimes it comes very easily to people, and sometimes we need to have a little bit more of an algorithmic approach, which means taking it step by step. And more practice is always best. So first things first, well, let's identify which is the independent and which is the dependent. Graphs or charts give us the independent variable first on top and the dependent on the bottom. Now you're going to scroll down and see, here is another way of expressing. We say the column on the left is our independent and the column on the right is our dependent. So we're going to see two different kinds. We're going to see a horizontal and we're going to see a vertically presented chart. But let's just focus on this one first. Let me just get those instructions in there. So, describe the relationship in words. Well, let's see. When we go up 1 in the independent, we go up 2 in the dependent. And specifically, this gives us a context. The figure number, 1, 2, 3, 4, 5, gives us the number of triangles that are given in that figure. So in figure 1 there are 2 triangles, in figure 2 there are 4 triangles, in figure 3 there are 6 triangles. So what we can say is, for every increase of 1 in the figure number, two triangles, or 2 more triangles are created. So this is the answer for A part. Now what we want to do is we want to create an expression using the independent variable. So I go up here and I see, okay, for every increase of 1 figure number, there is an increase of 2 in the number of triangles. So in our figure 0, this is kind of, this is what gives us our constant term. Since I'm adding 2 every single time I'm moving to the right, I need to subtract 2. So that means that our constant is going to be 0. So the way that I would write the expression is I would say 2f plus 0. Now let me just use my highlighter here because that can help us. So our figure is our independent. That's where we get this from. Our increase of 2 every time is represented by this 2 in front of the independent variable. And since our 0th term, or 0th figure has 0 triangles, that's why we're adding 0. So as our final answer, what we can just say is simply 2f, because we don't need that 0. From here, creating an equation is easy, because all we have to do is we just have to say the dependent variable equals the expression. So I say my t equals 2f. I'm just going to highlight where I got that t from, the same color. And that's that. Now what we can do is we can create our graph. Now the trickiest part about the graph is choosing an appropriate scale. But first of all, let's draw our axes. Now you notice that I used arrows, or I used lines with arrows at the end of it, meaning that it can extend in both directions. Now for our independent, that goes on our horizontal axis, so we just need to go from 0 to 5. So I'm just going to skip, I'm going to have 2 for every, 2 blocks for every one. So this is 1, 2, 3, 4, 5. And I'm going to label this figure F. Here we need to get to 10, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So every square can be 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I'm going to label this number of triangles. And I'm going to put my variable t. Now I'm going to plot it. 0 and 0, 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. Now the biggest question here is, do I draw a line here or not? Is it discrete, meaning we only have whole objects, or can I draw a line? Considering that we're talking about a figure number being 1, 2, 3, 4, or 5, there's not like figure 1.5 or 2.5. Neither can you have like half of a triangle or like 0.2 of a triangle. So we're going to keep these pieces of data, these dots, these coordinate points distinct. We do not need to draw a line to connect them. And we're done. All right, let's move on to the next one. First things first, let's describe the relationship in words. I'm noticing that I am adding 4 every single time I add 1 in the independent. So words. For every increase of 1 in term number, there is an increase of 4 in the term value. So if I were to write an expression, I need to figure out what my 0th term is. So if every single time I go down, I add 4, I'm going to subtract 4 to get my 0th term. So 6 minus 4 is 2. So I know that my constant is going to be 2, and we're going to multiply the term number by 4. So 4s plus 2. If I'm to create an equation from that, I'm going to say that the dependent variable, or my v, my term value, is 4s plus 2. And now I'm going to graph it. I'm going to label my horizontal axis, that's my independent, as term number. I call it S. And I'm going to label my dependent, or my vertical axis, as term value. It's getting a little squishy there. I'm just going to zoom in so I can fit it in. And now I am going to pick my scale. From my, well, for the horizontal, I need to go from 0 to 5. I know that one well. 1, 2, 3, 4, 5. And now I need to go from 0 to 22. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm going to have to go up by 2 every single time. So this one's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Now I don't have to label every single one. I can, if I'm feeling it's too squishy, I can just say this one's 4, 8, 12, 16. But I can fit in. If I zoom in. So let's plot this thing. 0 is going to be 2. 1 is going to be 6. 2 is going to be 10. 3 is going to be 14. 4 is going to be 18. And 5 is going to be 22. Now again, this is discrete because term number, you can't have term number 1.5 or 7.273. So this is discrete data, so I do not need to connect those dots. What about this one? Let's think about it before we even graph it or anything. Time in minutes and distance from the ground, d, in meters. Can you have 1.5 meters? Yes, you can. Can you have 7.253 minutes? You bet we can. So this is called continuous. It's continuous data, so we will connect the dots or the data points. Okay, first things first, let's describe the relationship in words. So for every increase in 1 minute, there is a decrease in distance from the ground by 5. So words, for every increase of 1 minute, the distance from the ground decreases by 5 meters. Let's get this into an expression. So that's just using our independent and finding out what our constant is going to be our first thing. So every increase of a minute, I'm subtracting 5. So if I go backwards in time, I'm going to add 5. So this is 55. So when t equals 0, we're 55 meters above the ground. So I would say minus 5t, because we're going down by 5 every single time, plus our constant, which is 55. To get our equation, that's real easy. We're just going to say d equals negative 5t plus 55. If we wanted to say that d equals 55 minus 5t, that's totally fine too. Either way, whatever makes most sense to you, you just can express it that way. So let's graph it. So I'm going to put, okay, I'm just going to put my dependent here. So I'm going to put time in minutes. And my variable is t. And distance from ground in meters as my d, and I'm just going to put here meters, just so we know. So I'm going from 0 to 5. I know I can go 1, 2, 3, 4, 5. And I need to go from, I need to go up to 55. So I think that my scale is going to be 5, and as long as I have 11 blocks, I know I can get to 55. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Ding, 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 ding. So I'm just going to, for every 2, I'm going to put 10, 20, 30, 40, 50, and 60. It's always good to extend it a little bit beyond. So we have 0 at 0 minutes, we're at 55. 1 minute, we're at 50. 2 minutes, we're at 45. 3 minutes, we're at 40. 4 minutes, we're at 35. At 5 minutes, we are 30 meters above the ground. Now you're noticing that the slope is different. It's going down instead of the other two examples that we have were going up, which makes sense because we're getting closer to the ground and our coefficient in front of our independent variable is negative. Now I am going to connect these dots this time because we have continuous data. There you have it. Now this one has no context, so we don't know if it's continuous or not continuous, and actually we're finding that the data points, we need to fill some in. Whenever you don't have any context, you can just assume that it is continuous data, so we will connect those dots with a line. But first things first, every jump in 2 gives me a difference of 17 minus 9, which is going to be plus 8. That means that if I jump just 1, it's half of that. So I'm going to just say plus 4. So 9 plus 4 is 13. Let's see if the same is the case here. From 17 to 25 is a jump of plus 8. So half of that, if we, instead of jumping 2, if we just jump 1, we're just going to jump up plus 4. So 17 plus 4 is 21, and that fits with the data points. Now 25 plus 4 is going to be 29. Fabulous. Now the only thing that we have left here is we need to find our zeroth term. So when we jump down 1, we go up 4. So if we want to go up 1 level, we're going to subtract 4. So our constant term is, or our constant value is going to be 5. So this one is a little bit stranger because we don't really have a context, but if I were to say in words, for every increase of 1 in the independent variable, there is an increase of 4 in the dependent variable. Now if we were to create an expression, I would say 4x plus our constant, which is 5. If I were to create an equation from that, I would say y equals my expression, 4x plus 5. So let's graph it. So this one I'm just simply going to label as x, and we need to go from 1 to 7. 1, 2, 3, 4, 5, 6, 7. Oh, look at that. I can, for every 2, I can make it an increase in 1 in x. 5, 6, and 7. And now here's the tricky bit. I need to get in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 into 33. What I'm going to do is I am going to go 3 for every block. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36, extending just a little bit beyond. So with 0 we have 5. Now this is going to be a little bit more approximate than the other ones. Well, that's okay. So 3, and then 1 will be 9. In fact, what I'm going to do is I'm just going to plot the points that have 3 as a, or have a factor of 3 in the dependent variable. So 4 is going to be 21. This will give me actually a more accurate graph. And 7 is 33. So now I am going to connect those lines. And I'm actually going to use arrowheads on both sides because it can extend past 0. You can't go into negative minutes, so it makes sense that we would have a definite starting point there. But we don't know the context, so perhaps the context will allow for a negative, for negative values. So that's why I created arrowheads on both. So in summary, this lesson gave us more practice in creating equations and graphing.